Good evening, students. This is Nirmala from BioTecNika, Bangalore. I am here to explain you regarding the online live demo class. So, as you all know, uh, like we at BioTecNika provide online live classes for life sciences and chemical sciences. And we are coming up with a new batch, the online live classes from 16th of May. Okay. So, I hope I am audible to you all. So the coaching classes what we have, it will be conducted in weekdays and weekend batches. Weekdays being three different batches. One would be morning 10 to 1, afternoon batch is 1:30 to 4:30 and late evening is 7 to 10 p.m. And if you're not comfortable going with the weekdays batches, we have weekends also. So the same way you're taking up the live demo right now, it will be conducted in the weekends. It will be Saturday and Sunday morning 10 to evening 5 o'clock. Okay. The same way the link will be shared on your email. Just click on that, you will get connected to the live session. Alright. And we also provide you the study materials, which is a set of 14 printed books, 13 books for 13 different units and one for the part A questions. So all these books will be sent to your home address through Indian Speed Post. So along with the coaching classes, you get the printed books, and one more unique feature what you get is our online study portal. So here you get all the recorded classes. Okay, whatever you're taking right now, it's being recorded. So you'll be getting the recorded sessions of them, the PPTs which are being explained in the class, the animations, previous year solved question papers, and also you'll have test series. As in when the topics are covered, you'll have weekly and monthly tests. Okay. So this is how the online class has been conducted. So let me just connect you to Dr. Abhiram now. So he'll be dealing with a topic on biochemistry. Okay. So you can just take up the live session right now, and if you have any doubts in between the session, you can just ask him. He'll clarify these things to you. Okay. All the best to you. I'm just connecting you to Dr. Abhiram right now.
Hi, my name is Divya Rajendran. I had joined BioTecNika to help me with my preparation for December 2015 CSIR exam and GATE BT exam. I have secured 65th rank in CSIR JRF exam and 210th rank in GATE BT. I found teachers of BioTecNika helpful, knowledgeable and very approachable. I thank them wholeheartedly for the efforts they have taken in teaching the subjects in the most efficient way possible. The tests that have been conducted regularly in BioTecNika helped me greatly with my CSIR preparations. I thank the entire BioTecNika team for their help. Thank you so much.
So this is Dr. Abhiram. I'll be taking a little bit topic on the carbohydrates, the structure and its chemistry also. So let me explain about the carbohydrates first. So firstly, you should understand what is the importance of studying the chemistry of carbohydrates. Because we are dealing with the biochemistry part, you should understand what is the biochemical nature of these. See, whenever I'll say biomolecules includes carbohydrates, proteins, lipids and nucleic acids. These all together will be referring as a biomolecules. See, you know the biomolecules have various functions and the metabolism and the regulation what happens in our body. Okay, so if you want to understand the metabolism and regulation of these biomolecules in your body, firstly you should know their chemical nature. What is their chemistry is all about. First you understand the chemistry, then you read biochemical role. That means the metabolism and their regulation. Then you can understand. This is how we have to study the biochemistry. Firstly, study the chemistry, then go for their metabolism and read the regulation part. Okay, so that the things will be clarified in a systematic manner. So let me speak something about the biochemistry here. So I am here taking a small part on the carbohydrates. So what do you know about carbohydrates? The name itself says carbohydrates. Hydrates means water. Hydrates means water. Carbo means carbon. That means this is carbon, this is hydrates. So total together I'll be writing as CH2O. Okay, now how many carbons? I don't know. So just keep as N. N refers n number of carbons. For example, if you want, if your N equals to 6, then just C12H24. Sorry, C6H12O6. What is this? This is your glucose. If you make it 12, it will be C12H24OL. Okay, so this is how you are taking the multiples. Like carbohydrates. Carbohydrates, hydrates means the water and carbo means carbon. So it is nothing but the atoms which are present in the carbohydrates are the carbon, hydrogen and oxygen. Okay, and coming to the structure, you have two different structures here. One, I'll say like carbohydrates are polyhydroxy aldehydes or ketones. See, I'm saying as polyhydroxy, that means it contains a number of hydroxy group. Aldehydes are ketones, that means it may be aldehyde or it may be a ketone. It never be a both. A carbohydrate may be a aldehyde or might be a ketone. Okay, for example, if you say a particular carbohydrate is a aldehyde, so I can say those carbohydrates as aldoses. Aldoses means Os. Os is a suffix. Os. This is a suffix which we are using for the carbohydrates. Aldose means carbohydrate having a aldehyde functional group, that is called as aldoses. In the same way, ketose. Ketose means it is a ketone functional group. Os. Os means it refers to carbohydrate. So I am classifying, for our simplicity, I am classifying the whole carbohydrates into two broad categories. One is carbohydrates, one is aldoses, other is ketoses. Okay, just a second, I will connect it to you. So far, do you have any doubts? So I am just classifying the whole carbohydrates into two categories. One is aldoses, other is ketoses. Okay, so I'm broadly classifying this: monosaccharides, oligosaccharides and polysaccharides. So monosaccharides, they are colorless, they are crystalline solids, they are freely soluble in water and they are sweet in taste. Now, one of the best monosaccharide is a D-glucose. D-glucose, what is this D first of all? Okay, the D. Now, moreover, dextrose, I am showing you here dextrose. That means glucose is also called as dextrose. Why glucose is called as dextrose? Because the naturally occurring glucose, first of all, you take a glucose sample, dissolve in a solution. Take a glucose sample, dissolve in a solution. Place it in the path of a plane polarized light. Place it in the path of a plane polarized light. What do you mean by plane polarized light? Plane polarized light is nothing but a light which has, that means which can propagate in one direction. The light which can propagate or which can travel in only one direction, that light is called as plane polarized light. If you pass that plane polarized light through your glucose solution, now your glucose solution can rotate the light towards the right side or left side. Okay, but the naturally occurring glucose rotates this plane polarized light towards the right side. Hence, glucose is also called as dextrose. Glucose is also called as dextrose. What is the reason? Because the naturally occurring glucose rotates the plane polarized light towards the right side. In the same way, you prepare fructose. Take a sample of fructose, prepare in a solution. Now make a solution of it. Place it in the path of a plane polarized light. Now the naturally occurring fructose rotates the plane polarized light towards the left side. Hence, fructose is also referred as levulose. Fructose is also called as levulose. What is the meaning of levulose? Levulose means the naturally occurring fructose rotates the light towards the left side. So glucose has dextrose, fructose has levulose based upon the rotation, their rotation to the plane polarized light. Are you understanding? All online students. See, in between, if you have any queries, you can clarify with me. Okay. Now, see, firstly, I'll be showing you this structure. See, whenever we are in 10th standard or intermediate, if your teacher asks you to write the structure of glucose, we know only one structure, that is C6H12O6. But once you are in your BSc or MSc, we have studied the structure of glucose as like this. This structure, I can say this as an open chain structure of a glucose. Now, firstly, you remember the open chain structure of a glucose, because as the class progresses, I will be showing you different structures of the glucose, because this is open chain structure of glucose. I will show you hemiacetal structure of glucose. From hemiacetal, I will show you Haworth projection structure. Okay, chair structure of glucose. See, each and every book follows different structures. Okay, see, if in the exam, if you have been given with a question on glucose, okay, they don't ask you simply as C6H12O6, or they won't ask you, don't expect the question to be like this. They may ask you anything. That means they may give the structure like this. They may give the structure like this. So firstly, you should able to identify that the given structure is glucose or not. So in order to identify the structure, firstly you should know how many different forms we can represent the same glucose. So instead of it, you have to learn how can we write these structures. Okay, so firstly let me show you one thing. Here you can see the carbons in pink color. Those carbons which I have represented in pink color, those carbons are called as chiral carbons. Chiral carbons. Here you can see here, those carbons are called as chiral carbons. What do you mean by chiral carbons? I can say chiral, or I can also say as asymmetric carbons. Chiral or asymmetric carbons. Chiral or asymmetric carbon means you have a carbon which is bonded to 4 different atoms or groups. Say for example chlorine, hydrogen, hydroxy, amine. I am just saying an example here. So this carbon, I can say this carbon is a chiral carbon. Why that carbon is a chiral one? Because that carbon is bonded to 4 different atoms or groups. Now, what is the significance of knowing the chiral carbon? Okay, you understood in the glucose there are 4 chiral carbons, and you understood what is this chiral carbon is all about. Okay. So you understood what is this chiral carbon and what is it all about. Now what is the use of learning? What is the use of knowing this chiral carbon means? A chiral carbon, if a carbon is chiral, if I say a carbon as a chiral, then it indicates that it is optically active. That it is optically active. If I say a carbon as a chiral, that means if I say this is a carbon which is chiral, it indicates that that particular carbon is a optically active. Optical activity, you should know the optical activity of the sugars. You should know the optical activity of these compounds. Okay, if you can refer the previous question papers, there will be several questions based upon the topic which is called as optical activity. You should know the optical activity of the carbohydrates, proteins, the nucleic acids. Are you understanding? So this is how optical activity. That means, for example, if I'll give you a structure, by looking at the structure, whether you can say that structure is optically active or not means, yes, I can say. How can you say it? How can you say? By looking at the structure, you observe for the carbon. If that carbon is a chiral carbon, then definitely that will be optically active. Are you understanding? Okay. So this is the one of the structure, and here I am showing you the 2 structures. One is glyceraldehyde, other is dihydroxyacetone. Dihydroxyacetone. So what is the difference between these two? Here I have marked already in yellow. This is a aldehyde group, and this is a ketone group. How many carbons you have here? You have 3 carbons. 3 carbons I write as tri, and this is aldehyde. So aldotriose. What do you mean by aldotriose? Here, how many carbons you have? I have 3 carbons. So it is tri. Whether it is aldehyde or ketone, it is ketone. It is ketose. Ose means it is representing the carbohydrate. Now, this is a different terminologies. That means once you go through the book, see, most of the topic what I have covered is from the linear only. Once you go through the books, you can't understand. But if you see these terminologies, because they won't give you a clear explanation, but once you see these terminologies, you can understand what is the meaning of aldotriose, what is the meaning of ketotriose. Aldotriose means it is nothing but aldehyde with 3 carbons. Ose is a carbohydrate. In the same way for the ketotriose. Ketotriose means it is a ketone with 3 carbons. Are you understanding? Now this is the terminology. These are the terminologies what you face in your textbooks once you go through the book. Okay. So 2 families you have aldoses and ketoses. This is the simplest aldose and simplest ketose. What is the meaning of simplest? Simplest means I cannot represent less than this. Less than this triose I cannot write. It is not possible. This is the simplest ketotriose. That means this is the minimum starting triose, minimum starting carbohydrate with a ketone functional group. So this is how you can see here: tetroses, pentoses, hexoses, and heptoses. Tetroses is a 4 carbons, 5 carbon, 6 carbons, and 7 carbons. Okay. For example, if I say the structure of glucose, how do you classify glucose? Whether it is a aldotetrose, ketotetrose, aldopentose, ketopentose, how do you classify this glucose? How do you classify this glucose means? Firstly, you say glucose, the functional group present in the glucose is aldehyde. So I'll write as aldo. How many carbons are present in glucose? It is 6 carbons. So hex. Yes, Nupur is very good. That is the right answer. See, aldohexose. Now, is the glucose is the only one which is coming under aldohexose? No. You have different. See, glucose, galactose, mannose, allose, aldose. There are several aldohexoses. But what is the use of knowing this? I can say if all these are undergoing similar kind of reactions, similar kind of transformations, then I can say this particular reaction is applicable for aldohexoses. Instead of saying this particular reaction is applicable for glucose, galactose, mannose, allose, I can say a simple term. This particular reaction is applicable for all the aldohexoses. All the aldohexoses means whatever you say, whether it's glucose, mannose, galactose, whatever it may be. Okay, in the same way, if you go for fructose, fructose I can say as this is a ketohexose. Fructose is a ketohexose. Okay, so this is how you can see here. Okay, now what I want to say especially from this slide is firstly you observe the names of everything. See, this is 3 carbon, 4 carbon, 5 carbon, and 6 carbon. Observe the names. I have represented the name as D. In front of every name, I have represented the name as D. What does this D indicates? Can anyone say? What is the meaning of this D? Because if you see for any structure I have ended, see the prefix what I have used is a D. D means it is not exactly rotation, it is not exactly about rotation. Okay, it is particularly about the configuration. Configuration means how you are arranging the atoms around the carbon. Okay, see, I already told you that your carbon, if it is a chiral, then I can write like this. Okay, this is a chiral carbon having 4 different atoms or groups. So it is chlorine. Okay, now if the hydroxy group is present on the right side, okay, listen carefully. If the hydroxy group is present on the right side, then it is called as D. In the same way, If the hydroxy group is present on the left side, then it is called as L. In the carbon, if you have a hydroxy group on the right side, it is called as D. If you have a hydroxy group on the left side, it is called as L. Okay, now if you have a structure, by looking at the structure, whether you can say it is as D or L means yes, I can say. How I can say means, you should not observe all the carbons. You should observe that carbon which is present last but one. That means you have a alcohol here. Just see this carbon. Everywhere you have to observe only this carbon, not any other carbon. See, if you observe, for example, if you observe here, no, it is wrong. Because here you have a hydroxy group on the left side. You should not observe to any other carbon. You have to observe the carbon which is present to the last but one. This carbon. In this carbon, if you have a hydroxy group on the right side, then it is called as a D configuration. If you have hydroxy group on the left side, it is called as L configuration. So in this way, all the carbohydrates, all the naturally occurring carbohydrates, they are D sugars, and all the amino acids are L amino acids. Why the amino acids are L amino acids means, in the amino acid we don't have a hydroxy group. So what we have means, it is the amino group what is present, like this. If amino group is present on the left side, then it is called as L amino acid. All the naturally occurring sugars are D sugars, and all the naturally occurring amino acids are L amino acids. Yes, students, are you understanding? So far, do you have any doubts? So this is about the optical activity and all these things. Okay, like you should know something about the optical activity, right? Okay, in the exam also, whenever you will be asking, you should know about the optical activity. I'll show you one more thing, like yeah. Now, you know the structure of glucose. You know number of chiral carbons present in the glucose. Okay, now how many stereoisomers? If you are asked to find out the stereoisomers present, okay, if you are asked to find out the number of, for example, the question, number of stereoisomers possible for glucose, number of stereoisomers possible for erythrose. So, in order to find out the number of stereoisomers, firstly you should know how many chiral carbons are present. It is not how many carbons are present, remember. Okay, understand carefully. It is not about how many carbons are present, it is about how many chiral carbons are present. Okay, for example, in glucose, you remove the first one and the last one. Every case, you remove the first one and the last one. For example, erythrose, it is a 4 carbon one. How many chiral carbons? It is 2, because I am eliminating the first one and the last one. The first one and the last one in all the carbohydrates, those are not the chiral one. Okay, especially aldoses I am saying you. Especially if you speak about the aldoses, the first carbon and the last carbon are not chiral. Okay, that means the formula what we are using is 2 power n. 2 power n is the formula. N is nothing but number of chiral carbons. So, for example, you can see here, how many isomers possible for glucose? How many stereoisomers are possible for glucose? You just tell me. How many isomers will be possible? So, yes, very good. You have total glucose has 6 carbons, you can see here. Okay, the one which are marked in color, the 2, 3, 4, 5 carbons, these 4 carbons are chiral carbons, whereas the first one and the last one is not a chiral, because you can check, because the 4 groups are not different. So it is 2 power 4, that is 16 isomers are possible for glucose. Okay, so this is how we are identifying the stereoisomers present in glucose. If you go for fructose, okay, see the structure of fructose is different from glucose. Even though fructose is having same 6 carbons, Okay, but the number of chiral carbons present in the fructose is only 3 and the number of stereoisomers possible for fructose is 8. Okay, in the fructose, the first, second and the sixth carbon, these are not chiral carbons. Because if you see the structure of fructose, you have like this. Okay, these three are not chiral. Are you understanding, students? This is the difference. See, fructose and glucose is both are C6H12O6 only. Okay, but once you write that C6H12O6 in the form of a structural representation, okay, the number of chiral carbons are differing. The number of stereoisomers what you get is differ. For glucose it is 16 isomers and the fructose it is 8 isomers. Is it clear so far? Do you have any doubts? Yes, you can type it there. If you have any queries, you can type. I will clarify your doubts. Okay, so see that my aim is that, see, first of all, whenever you're studying the metabolism or regulation, don't study directly. Okay, if you start open the Krebs cycle, open the HMP shunt or glycolysis, okay, you don't understand. Firstly, go through their chemical nature, understand their biochemical role, go through their chemical nature. Now you start reading this. Definitely you can understand. Okay, so this is how you have to practice for studying the biochemistry especially. Okay then, so if you have no queries, I'll stop the demo at this stage. Okay, thank you students, thanks a lot.
So students, I hope you got an idea of how exactly the online live classes are being done, right? So this was just a small topic which we dealt with today. So further, when you enroll for the classes with us, like daily 3 hours class session will be conducted, okay? And it's like rather coming to the classroom coaching here, why don't you just sit at home? Like it will be saving enough time for you. This will be as good as the live classroom coaching. Okay, so and the preparation what you're going to take up from BioTecNika, it will be helpful for your CSIR net, your GATE exams, ICMR exams also. So rather searching for the best things, do not search so much for this. Okay, it's now you'll have to don't you shouldn't spend so much time to choose the perfect opportunity, that you'll miss the right opportunity. Okay, so now do not make it too late. We are starting a fresh batch from 16th of May. Okay, that is on Monday, as I've already told you. So you can get in touch with your like you were in touch with my colleagues here, so you can talk to them, you can take the information from them. So 14th of May, that is Saturday, would be the last date of enrollment. Okay, and make sure you enroll as soon as possible, because we are also providing you lecture DVDs for free. Okay, along with the other materials what I've told you earlier, you'll be getting 4 sets of lecture DVDs which would contain all the important topics, best lecture videos in them. So make the best use of this opportunity and grab these DVDs also. Okay, and to inform you all, we take only 15 students per batch, so whoever comes first, you will be getting a seat in this particular batch and your batch of choice. Okay, so we will get back to you shortly. Meanwhile, you will also think of your enrollment. You can just think well, decide, and you can get back to us if you have any further queries. Okay, so do you all have any question? Okay then, I'm sure the things are clear for you. This is how the online demo, this was just an online demo class. This is how the live sessions are being conducted. Okay, all the best to you. Okay, I'll talk to you soon. Yeah, thank you.